Welcome to another episode of Big Rep Experts. My name is Michel. As you know, we're in the business of large-scale printers and prints. Today I'm going to explain to you and go with you through the tools that allows us to control specific parameters for specific areas of the large prints. So in this case, we're going to print this large bust. My interest here is to maintain the shortest print times and obviously the minimal usage of material. Therefore, my natural tendency is to use a very low infill density. In this case, 4%. I know from experience that 4% is pretty much enough for most of the prints. But when we come to the horizontal portion of the print, that is the shoulder areas or the top of the head, we need more infill in order for the surfaces to close perfectly. And in this case, I'm going to show you how we use these tools. In this case, 4% infill density. The only problem I might encounter, so the density is very good for most of the print, is in these areas where the shoulders and the top of the head, they have too much horizontal portions and material might collapse into the cavities and not print properly. Now I'm going to manipulate it and I'm going to show you how we control the different areas of the print with different parameters. So first of all, I'm going to click on the model itself and then I'm going to create a support blocker, it's called. And then I'm going to position it and scale it to the size I want. In this case, this is roughly the size on all axes, then a little bit the y-axis, x-axis. Now I have a nice cube. I'm going to position it right at the shoulders of Mr. Socrates. And then I'm going to click the cube and control its parameters. So I have this very nice toolbar here that allows me to decide what this support blocker will do. One option would be print as a normal model, the other one print as support. Modify setting for overlaps, this is the parameters we're interested in, and don't support overlaps. So I'm going to click this and it gives me a few settings on which I can control, but I can also select setting out of a list of predetermined settings. This list is very long. In this particular print, we are interested in infill density. I want to control the parameter of infill density. So I add it here, and here I'm going to click 12%. Yeah, from experience, I know that somewhere between 10 to 15% is good enough for the surface to close correctly. So I'm going to slice it now and you'll see the difference. If I would like to print the whole bust with 12% infill, it will take me much longer. So as you can see, my file is optimized. I'm printing most of the bust using 4% infill, but then where I added the support blocker, it densified the infill to 12%. And this is where the horizontal portions of the print will print better. And I'm highly probable to have the surfaces I need. If I was to print this right away, I would repeat it for the top of the head, but this is something we keep for you to do or for other videos. Let's move on with the other case. In this case, I'm going to share with you a real use case of a client. This client came in with a request to print a propeller blade, a very large propeller blade, which is made to be prototyped, therefore used underwater. So the requirements were very clear. He needs a very strong part. But obviously, pricing, material usage, and print times play an important roles. As we said, we are in the business of large-scale prints. So that's why we need to optimize his print. The goal here would be to reduce the print time and the material usage, but yet we have to make absolutely sure that where the propeller connects to the hub, to its hub, with using screws, the portions are strong enough. So what I do is the same as with the bust. I'm constructing this cube here on which I will control the infill density around it. So I just showed you how to do it on the bust, but here I also added the infill patterns, which I would like to control and make concentric. So essentially I have a hole and I want to have a lot of material around it to, I'd say, perfectly snug the screw that will screw this propeller blade to the hub. Okay, as you can see, the propeller is fully printed, 1 day and 12 hours. I can go through it and show you the infill densities is at 20% with a suitable pattern, but yet now I'm going to look at the infill density of the cube itself was set to 100%. Fully infilled area around the holes in this way. So I know that my plastic is fully dense in the area where I need it to be strong. That's another very smart use of this feature. So this was another example of how we can smartly use our Big Rep blade features. Another video of Big Rep experts. Please subscribe. See you next time.